Okay, so
Skunk jumped the stump.
it's too late. We're live now, and that's staying in. So we're here. We're going to talk about Thermahive. We're with Daniel, Alexis, and Terrence. And by the way, I know that a lot of people are going to look at this and think this has been tried a lot by a lot of different people. So you've got a big challenge ahead of you to convince us why you're looking into it, what kind of testing you're doing, and what we're talking about today.
Yeah, so I'm Daniel. I'm the founder. This is my wife, Lexi, and Terrence. He's also a co-founder. Terrence and I are engineers, and Lexi's a biologist. So we are actually not beekeepers yet. We're becoming beekeepers, but creating, designing, and testing things is what we do. So while I was in school, I heard about this problem and started looking for a solution, and found heat was very effective, but that there was a gap in the market. And so that's where this was born. And we've been designing and going full time at this for the past 6 months. So this is the first prototype. It's engineered with fluid dynamics and engineering principles to be very efficient, reliable, even heating, and fast.
Okay, let's run it down, top to bottom. How's this configured?
So in the top here, we have 2 fans for ventilation. These are programmed to be very gentle and mimic what bees do to control the environment themselves. We have exit holes here that have been designed to ensure we don't choke the system, and it ensures that there's even distribution of heat, even if you have multiple stacked brood boxes, mediums, honey supers. This controls the heat flow very evenly. In the middle here, we have whatever your setup would be. So right now we have 1 deep brood, and the bottommost deep brood box or medium brood box, you would drill a 1/2-inch hole. This is the only setup required, and that is where our temperature probe goes. So we spared no expense with the temperature probe. It is the golden standard for temperature probes, and it goes right where the critical zone, where the thickest part of the brood is, to ensure treatment there is the most complete. However, it's very even heat all around. And so we have a diffuser plate here that you can feel is warm, but it's not gonna burn you or the bees. And so this breaks the airflow up and allows for an even distribution of the heat that is coming in at the bottom. So at the bottom, we have a forced air convection. So there's a fan right here that draws air in, and then there's a heater that is given heat through electricity down here. And so the air coming in gets pushed through the heater and allows for very hot and fast movement of heat. And we have 2 relays down there for safety to control it. So if one were to fail, the other one would back up and you wouldn't burn your hive alive. And so a lot of work went into this controller. It's a custom controller, and you can see I took the probe out, and so it dropped down, and it'll bump right back up to 112. But this is a controller with our own algorithm here to ensure it never drops below your set point temperature, and it only goes above it by 1 to 2 degrees. You can also set the time and the temperature yourself, so you can figure out what works best, since there is no hard consensus in the scientific community of what is the most effective.
Okay, so thanks for that rundown. A lot of these are sensors, and you've done a really good job laying this out. Let's talk about the bees. Let's go into the biology, right?
Okay.
The bees leave that on. Or yeah, you can pass it on to her. So we know that the honeybees, when they're stressed with heat, they do start fanning, they start doing all the air movement. They're trying to survive an elevated temperature. And one of the complaints about systems like this is the amount of time it takes to get the bees and the brood area, which is where they're defending it the most.
Yeah.
Right. So you have to get the brood area to a temperature where the Varroa mites, even under cappings, are going to die. Have you established what that thermal range is where the bees are still okay, but the mites are done?
So there's limited data out there right now on what is optimal. However, based on the research that Randy Oliver did, which was really like our foundation for developing this, we estimate that the ideal treatment temperature is somewhere around 112 degrees. That's in Fahrenheit. And then likely for about 2 hours would be the length of the treatment time. Since this is such a fine line between what is like safe and what is not, that's the reason we had to have something that was very precise and evenly heating. So that was what they worked on addressing. And, you know, we read through his whole article on hyperthermia treatments and kind of looked for what were the issues he pointed out with existing treatments and kind of went from there. So we said, okay, you know, uneven heating or doesn't get hot fast enough, then like how can we make this better?
And this is partly what the fans are going to do, right? Is regulate and kind of normalize the heat throughout the entire hive.
Yeah.
And you have not done live testing yet?
Not yet. We didn't have a working prototype until this fall.
Okay.
So we are planning on doing live testing this spring. We've already got several testers signed up who are going to...
Are there any names we would know of people that are...
Actually, this is one of them right here.
Troy, your commercial?
No.
He's just going to be one of our testers.
You're just going to give them your bees?
We're giving him...
Testing unit, I bought a unit.
Oh, you bought it. Okay.
Yeah.
Now, how close will you be able to monitor how he uses it?
So inside of the controller unit, there is a SD card that will help collect the data about the temperature and everything. And then what he would be responsible for as part of like being a tester would just be monitoring the behavior of the bees, you know, writing down if you notice any observations, you know, does it make the bees start bearding?
Okay.
And then also just noting mite counts.
Pause on that. You mentioned the bearding.
Yes.
Are you allowing the bees to exit the hive?
Yes, they can exit because the brood is our goal.
So what if the mites migrate to the bees that are exiting the hive? This is a common criticism.
Yeah.
Because often these test units will have bees all over the outside, and the mites are very mobile bee to bee.
Yeah.
So they couldn't do anything about the mites that are under the cappings. They can't go anywhere, so we could really do that.
Yeah.
Which, by the way, not to throw a monkey wrench into it, but even the ability to do this to cap brood without destroying the brood, even without the bees. If you had a method of cycling them into another box where they get that treatment and we've killed that, the rest of the mites are dispersal phase, you could kill them all off with another treatment.
Yeah.
But I also understand that defeats the treatment-free crowd, which is attracted to the thermal dynamic you're trying to use. What do you think about that?
So,
you want to take this?
So as far as the mites on the bees, I think that if we can kill them in the cap brood, then that will reduce the amount of ones on the bees because we're stopping the life cycle. And that's really important for Tropilaelaps as well because they don't typically come outside of the brood as much, and they're a lot harder to find, and they reproduce a lot faster. As far as the brood itself, that is one of the things that we really want to understand better and help the community understand better is where is that limit for both the brood and the queen sperm. And so that's why we have done 2 hours as the limit, because some research not related to heat treatment as a treatment method, but related to other things like transporting bees, heat waves, have shown to be harmful towards queen reproduction. And that's where a lot of the research is for the threshold for larvae as well. So that's why we've set the threshold to be 2 hours, because that collage of research shows that should be safe for the larva.
Okay, another side question. Humidity levels. How does that
Humidity
play?
levels. Yes, so that's another thing that's one of the most unresearched parts about this. And from what I've seen, that humidity is harmful towards bees, but also it can be less effective for heat treatment if it's a hot, dry treatment. And so one of the things we're working on is adding humidity in the future based off of our testing this summer, that's something that we may look into adding.
Yeah, because if you drop it below 65% relative humidity, we risk desiccating the brood.
Yeah.
So is that part of your evaluation?
Yeah, absolutely.
It is, okay.
And our temperature probe, our sensors, they all monitor for humidity as well.
Okay, all right. Any last comments? When is this going? The guy that was just here said he bought one.
Yes.
So they are for sale?
They are for sale right now.
Okay.
We only have a few spots left for this batch at the expo.
Okay.
We plan to make more, but this next phase, we're going to start moving into the phase of research and development again, and trying to make this, based off of all the feedback we've got from the expo, make this more and more applicable to the masses of beekeeping. Still not quite with a focus on commercial, but working up to that. That's a harder problem to solve and definitely a harder market to tap into. But we want to be able to help all beekeepers with this problem.
Price point?
Price point right now we're selling for $500 early access, since there haven't been bees in it. But we're not really making any money off of that, so it would obviously be more expensive once we full launch this.
And we're just plugging into regular household current?
Yes, sir.
Have you thought about mobile power stations, what that would have to look like in order to get it through 2 hours?
Yes, it's absolutely possible right now. It's just more expensive, and we're trying to keep it as affordable as possible. So we're working, and we're going to work harder on that and try and make it mobile for everybody.
All right, well, I want to thank you for your time. It's a really interesting concept, and I'm sure you're going to get some feedback after we post this. And I just wish you all the best. Thanks a lot.
Pleasure.
Thanks, Alexis.
Awesome, thank you.
Good job. Yep, and we're out.